Welcome back to MPB. We're learning Algebra 1 today. We are now in Unit 7, working with quadratic functions. So we've learned all the introductions to our quadratic functions. We've learned all the parts and the features. Now we're going to take all that information and we're going to work with them. And we're going to go more in depth with what we've learned. So let's look and see. We're on our Lesson 1, Features and Vertex Form of Quadratic Functions. We're looking at IF4. I can use the vertex form of a quadratic function, which also creates an equation from the function's graph. So let's just dive right on in. So let's do a quick review. We know what our function is. So on your notes page, I want you to go ahead and label those different parts while I label them up here, and let's make sure that we're remembering what we've done. So my vertex I have down here. Let's go ahead and put my vertex here. In this vertex, I have a minimum. It's the lowest point of this parabola. My x-intercepts are where it crosses or touches my x-axis. And then my y-intercept is right here. Let's go ahead and put those coordinates. -4.5, 0, and 0.5, 0. Then right here for my y-intercept is going to be 0, -1. Then it says for me to circle my roots. Now, let's remember what those roots are. When we said that we found a root for our quadratic, it's where my parabola does what? Yes, it's where it touches or it crosses my x-axis. So it's going to be there and it's going to be here. There you go. So those are vocabulary that we've learned, features that we've learned. So now that we've got all that, let's take these and dive into specifics for these quadratics. So let's look. So new vocabulary, we have symmetry, axis of symmetry, and vertical form or formula. Now, these are brand new vocabulary. What I want us to do is I'm wanting us to get just a little bit more detail before we really use them. So when we find something that's symmetrical, that means it has the same features on one side of it as we do on the other. Just like your face. I have an eye and part of my nose and a mouth on one side of my face, just like on the other side. So if I folded my face together, they would cross or touch. My eyes would touch, my nose, and then my mouth corners would touch. It's symmetrical. That would be that my face is symmetric. Now, the axis of symmetry is where I can fold these, and then it would fold in on itself. And we're going to look at that a little bit more in a minute. And then my vertex form and formula. My vertex form. So I want us to go ahead and just write this down. We're going to write it again, but I want us to write it down just real fast. I have A times x minus h squared plus k. So this is going to be my vertex form and vertex formula. This is brand new. So let's look at some more. It says use the same graph that we reviewed with, and let's look at the symmetry and how to find it. Well, the first thing, let's go back and ask ourselves, what did we say symmetry was? When we talked about our face, one side of my face was the same as the other. So then let's see exactly what our definition means. It's balanced and proportional, similarities that are found in two halves of an object. So if I wanted to say this paper is symmetrical, I would be able to fold it, kind of like when you fold hot dog style, and I make my crease. Everything over here is the exact same as everything over here. It's just on one side of the paper and the other. So I could say that the line where it is symmetrical would be right here at my crease. So if I took this same concept that I folded this paper to this parabola, I could fold this side of the parabola to that side of the parabola. So let's look and see what that looks like. Well, where do you think I would fold that at? Yeah, I think I might want to try and fold it down my vertex. Well, where's my vertex? Right there. So what I'm hearing you say is if I fold it down my vertex, I should have symmetry. That's interesting. Let's look at some more. So when we think about a quadratic, we would fold it like we did our paper down the middle through the vertex, and that's what you told me. It's always on the x coordinate where we can fold it, and that is called our axis of symmetry. Now, you know in your different science classes you learned about the axis that goes through our earth. Same thing here. We have an axis that goes through our parabola. It's all the way down the x value of our vertex. And what did we say our vertex was? My vertex is right here. Well, what is that x value? It's -2 and -3. So this right here is where my axis of symmetry would be, -2. So my axis of symmetry is going to be at -2. Good job. Let's look at a different parabola. Now, the blue line with all the different points is our parabola. We can see where we have our x-intercepts. We see our y-intercept. We see all these different types of points on here. We see even what the quadratic equation is. Y equals x squared minus 3x minus 10 squared. So then it asks us, where is the axis of symmetry? Well, I have point to point, 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 and point to point. So where would my axis of symmetry be? Where's my vertex? It's between my whole numbers. So I would say, let me get a different color so it's not blue. I would say that my vertex is about right there. So let's say 1.5. So if I folded that, all those different points, they would fold on themselves. They would line up. So everything on the right side would definitely be symmetrical and have symmetry to the left side of that parabola. So then it says sometimes the axis of symmetry will not be a whole number on the x-axis. That's true. It can be a fraction, it can be a decimal. It has to go through that x value of the vertex. All right, so let's look. Let's do some practice. The graph shows the height of a kickball from the ground to the highest height, then back to the ground. Use this graph to answer the questions. So, as we always do, let's analyze our graph, see the information we can get, and see what we can use. So let's look. I have the height on my y-axis. I have my time on my x-axis. I see where it would touch or cross my x-axis. I see the highest up here. All right. So then let's start with these questions. What is my y-intercept? So what would we say my y-intercept would be, where it touches or crosses my y-axis? Yes, exactly. It's at 0, 0. My next one says, what does that represent? Now, it's very easy to say, oh, there's y-axis, there's where it touches. But now I'm having to put meaning to that point. What is the meaning to that point? Yes, so maybe the kickball is right here with it laying on the ground at 0 seconds, and the height at 0 seconds is 0 feet in the air. Good job. All right, number 3. Does this graph have a or an x-intercept? It sure does. My x-intercept would also be, let's get another color, 0, 0, and then what? 12, 0. Good job. What are they? And we put those. So then what do those 2 points represent? Yes. So my kickball starts at 0 seconds at 0 height, and my kickball gets back to the ground at 12 seconds with 0 height. Good job. Let's look at the next one. What is the highest height the ball reaches? Now we put a point up here. What can we say that height is? I'm thinking it's going to be what? About 40 feet, I would say, if I had to guesstimate, because I don't have the lines going across. So I'm saying it's about 40 feet is what I would say my highest height is. Now, number 6 asks, where can we say the graph increases and decreases? So let me get a color for my increase, and let's use purple. So the ball starts at 0 seconds and 0 height. And we kick it, and it goes up, 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 up to 40 feet. Now, what happens to that ball at 40 feet? Starts coming back down to the earth. So then we could say at 40 feet, it's doing what? It's decreasing. So let me get another color for decreasing. Just use this one. So now it's decreasing. So then it says, where is it increasing or decreasing? So I would say it increases in the interval of 0 to 40 feet, and then it decreases to what? From the interval of 40 feet to 0 feet. Now, when we talk about intervals of decreasing and increasing, do we look at our x-axis or do we look at our y-axis? Exactly right. We look at our x-axis. So now that we know what the height is of the increase and decrease, let's go back and see those intervals of time that it increases and decreases. So let's look. We get another color. Let's do red. So what is my time interval that it increases? It increases from 0 seconds to what? About 5.5 seconds. So that's actually when it's increasing. So when is it decreasing? So from about 5.5 seconds to what? About 12 seconds. So this is actually when it's decreasing. So it increases from 0 feet to 40 feet. And then what interval does it increase with? It increases that 40 feet from 0 seconds to 5.5 seconds. So it decreases from 40 feet to 0 feet. But what interval does it do that decreasing? From 5.5 seconds to 12 seconds. So that would be the intervals in which it increases and it decreases. So let's look at some more. It says, what is our domain and range? Whew, it's been a while since we had that question. So I would say that my domain, which has my x values, would be what? What would we say that my domain would be? So my domain would be 0 to 12, and my range would be what? Well, we really talked about it a while ago when we were looking at how we went, and then we came back to the ground. So my range, which deals with my y values, goes from 0 to 40. Let's see, it asks us, what is our axis of symmetry? Well, we've kind of already drawn that axis of symmetry when we were looking at what time it was when we got to that 40 feet. And what was this? Here is my axis of symmetry. And we said that it was 5.5. Now, here's the question. Could we use this graph to write our quadratic equation? We can, but we need a little bit more information. So let's look and see what that means, getting more information. When I have to write an equation from this graph, we think of our standard form, ax squared plus bx plus c. Now, obviously I could find my c, which is 0, where my graph crosses or touches my y-intercept. But the other two, I'm not quite sure how I would get those. So for us to be able to write an equation using this graph, I'm going to have to really focus on that vertex. So let's see what that looks like. We have created linear equations from our graphs, no problem. But now we're wanting to use our quadratic graph and write equations with that quadratic. So let's look and see what this says. We know standard form, but there is another form of a quadratic equation, and it's our vertex form. f of x equals a times x minus h squared plus k. Now you're thinking, Ms. Killen, we've used x's, we've used y's, we've used a's, b's, and c's. We haven't seen h and k yet. We haven't. H and k deal with your values of your vertex. Remember, our vertex has an x and y value, but we just can't put x and y again because we're going to get mixed up. Well, which is this one? What is that one? So what we've done is we've used h and k. H is going to be my x value of my vertex, and k is going to be my y value of my vertex. So on our notes page, let's go ahead and label this formula, okay? So here we go. A times x minus. Now, it's not a minus, that means opposite. Then we have our h. So then my h is going to be the vertex x value, and then my k is going to be my vertex y value. All right, so my subtraction sign means it's going to be opposite of whatever the x value is. My h is going to be the x value of that vertex, and that k is going to be that y value of that vertex. Now, Ms. Killen, you hadn't told me anything about a yet. Well, let's see. A determines if the graph is going to open up or open down. If it's positive, it's going to open up. If it's negative, it's going to open down. It also determines if the parabola is vertically widened, which is compressed, or if it's stretched, which is narrow, kind of like when we take a rubber band and we stretch it, or if we push it down, it compresses and gets wider. So that A has real big job for us. It's going to tell us two different things. So let's look. So here's the steps of this equation from this vertex form. My subtraction is telling me to do opposite. My H is my X value of the vertex. My K is my Y value of the vertex. Make sure we can see that. Now, here's my steps. Now, the steps should be on your notes page already, but I want us to go ahead and read over these again, okay? So let's look. The first thing we're going to do is we're going to sub the vertex H and K for the coordinates, and we're also going to use another number. Number 2, I have X and f of X, which is Y, and I'm going to plug those into that formula that we've already gotten. I'm going to solve for my A, meaning I'm going to get A by itself. Then once I find those, I'm going to sub those values in and have that A in vertex form. So we have what the formula is. We have our 1, 2, 3, and 4 steps. Now let's use this and work some problems. We're going to go back and look at here. We had 5.540. So what I want to do is I want to use these numbers and I want us to solve for that A. So let's go ahead and do this. I'm going to work it up here. You see if you can work it on your paper as I'm working it, okay? Here we go. First thing I'm going to do is I'm going to write this. F of X equals A, X opposite, so that's negative 5.5 squared plus my 40. So then I have to use another point as well, what it tells me. The point I'm going to use is my y-intercept. And what did we say that my y-intercept was? 0, 0. If we need to, we can flip back to that other piece of paper and we see right here, it's 0, 0. It's 0, 0 right there. All right, so let's flip back to our paper. So then I'm going to plug this 0, 0 into it. So I have f of x, which is my y value, 0 equals a times, my x value is 0 minus 5.5 squared plus 40. I'm going to solve for a. That's the only variable that I have left. So I'm going to solve for that a. So let's see. 0 minus 5.5 is negative 5.5. When I take negative 5.5 and I square it, I get 30.25 and then plus 40, and this still equals 0. Like we have done ever since we've started using our letters, we have to get that variable by itself, meaning everything is done with the opposite operation, yes, and then we're going to get a by itself. So let's see. I'm going to subtract 40 on both sides. So negative 40 equals a times 30.25. To get that a by itself, I am going to divide by 30.25 on both sides. So my a equals negative 40 over 30.25. Now, Ms. Killen, why did we do all that? Well, remember, we're trying to write a quadratic equation. So now that I have my a, I can put in all of my information. So let's look. Let me get a different color. I have f of x equals a, which is negative 40 over 30.25 times x minus my x value of my vertex, which is 5.5 squared plus 40. So I have my quadratic equation. Now, Ms. Killen, are you sure we did it right? Okay, pick up your calculator or click on Desmos. Let's plug this equation just like it is into Desmos and see if we get the same graph that we had. Okay, so here we go. All right, so instead of f of x, I'm going to put y equals negative 40 over 30.25 parentheses x minus 5.5 squared plus 40. All right, so let's move this. Remember, I can, there we go. There. So it does represent what we had as our first graph. Using the formula, we found our equation, and it shows that we do have the same graph. Good job. Steps to write an equation in the vertex form as we graphed are these, and we know these. So now let's look at this graph and see if we can get some information from this graph. Well, this and this is my what? My x-intercepts. This is my what? My vertex. And this is my what? My y-intercept. So let's go ahead and write those coordinates. So what do you think those coordinates would be? All right, so this one would be negative 4.5 comma 0, maybe 0.5 comma 0. This is -1, and this one is -2 comma -3. Check and see what you've got. Look to see what I've got and see if we got the same thing. All right, so now I want us using this information to write a quadratic equation. So I'm going to go to our next slide so I have a little bit more room. I'm going to put these numbers back. Negative 4.5 comma 0, 0.50, 0, -1, -2, -3. So I have f of x equals a times x minus my h squared plus my k. Now, let's figure out what we're going to put in here. This is my h and this is my k. So it says that the subtraction was the opposite. So let's go ahead and write that. I have x plus 2 squared and then plus what? -3. Well, when I add a negative, that's just like what? Subtraction. So let's put that. So I'm going to erase that, and I'm going to put minus 3. So now I know I have to use another number. Miss Killen likes to use her y-intercept. That's just how I've done it. Could you use your x-intercept? Absolutely. Could you use maybe a point up? Yes, you can. Just another point. I'm going to use my y-intercept just because I always do it that way. So let's see. I have my x and y value. So let's plug that in. I have -1 equals a times 0 plus 2 squared minus 3. Got to get that parentheses gone. 0 plus 2 is 2. 2 squared is what? Yep, it's 4. I'm going to move that k, so I'm going to opposite operation. Now, a times 4, I'm going to divide my 4. So a equals 1/2. All right, so now that we've got our a, let's go back and let's plug all of the information in. Here we go. So I've got f of x equals 1/2 x plus 2 squared minus 3. Look what you did. Look what I did. Let's make sure our math works. Let's review our math. Added 3. -1 plus 3 is positive 2. Divided. Got a 1/2 because 2 over 4 is 1/2. Plug that in, and there we go. Good job, guys. Good job. All right, let's go to the next one. Now this is time for you to master. When I have these for you to master, there's always that uncertainty, because sometimes I get like that. But for me to be able to come above that uncertainty, I need to remember to work all of my steps, read my passages, and analyze my graphs, because those graphs are going to give you more information than I ever could. So let's go ahead and look at these. Use the following graph to answer the question. State the 6 features that we've learned in this lesson, and then write an equation. And here's your hints. Your x and your y intercepts, your vertex, your min and max, roots, your axes of symmetry, and then label them. So go ahead, either you or you and your table partner try these, get your answers, and then come back and let's see what we got. So now that we've done this, let's see if Ms. Killen can get the right answer. Here we go. First thing I'm going to do is look at my graph and find all of the correct information that I've got, because I want to make sure that I get this correctly. So I'm looking first right here. This is my vertex and my axis of symmetry, and I have -3, +4. Then I have one root or x-intercept, which is -5, 0. And then I have another root, which is -1, 0. All right, I know that my axis of symmetry goes down the x value of my vertex. So I've got my x and y intercepts. I've shown my vertex. Now, is this a min or a max? This is a max. This is the maximum of this quadratic. So I am increasing, 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 and then I'm decreasing. So that's the maximum. All right, so then I've shown my root. This is a root, and this is a root. And then I have my axis of symmetry. Now this other question says for me to write the equation. Well, we're going to have to use that new formula that we've learned. So let's go ahead and write that down. So I've got my f of x equals a times x opposite of h squared plus k. So let's go ahead and label. It's just easier for me to label them. I have h and k, and then I'm going to use this other point. But Ms. Killen, you always use that y-intercept. Yes, I do, but I want to show you that you can use other points. So we're going to use that root. So here we go. So I'm going to have a times x opposite of h. So it's going to be plus 3 squared plus 4. And then I have my, let's put my other point in there. I'm going to put that other point with a different color. So I have my y value of 0 equals, it's going to be -1. And then let's go back to my other, plus 3 squared plus 4 in my a. So let's get rid of that parentheses. -1 plus 3 we know as 2. All right, 2 squared is 4. Trying to get that a by itself, I'm going to do opposite operation. -4 equals a times 4. I'm going to divide by 4. So what does my a equal? -1. It's negative and it opens down. So right there, my a a while ago was positive and it opened up. So it does prove to us that negative a's open down, positive a's open up. So let's go ahead and finish writing this equation. So I have f of x equals -1 times x plus 3 squared plus 4. Look what you got. Look what I got. Make sure that my math is what you have. Make sure that even if you didn't use that root that I did, you should still get the same number. All right, let's see what we got. It says that I don't want to forget what my vertex is. That's either going to be my min or my max, my h and my k values. How do we know the difference from the min and max? When it opens down, I have a max. When it opens up, I have a min. What are my roots? That's where my parabola touches or crosses my x-axis. My axis of symmetry goes straight down through my vertex, through my x value of that vertex. And we learn the vertex form, which is f of x equals a times x, opposite of h, squared plus k. Make sure you always read your graphs for all the possible information that you can get. I'm so glad that you came to learn here with us today in this new chapter. I'm so excited. I want you to have a great day.